import the required packages. We are going to need something to deal with any operating system commands. Import numpy as np, import pandas as pd, and import matplotlib.pyplot as plt percent matplotlib inline. So the OS package is really just so we can do any admin we need to do. NumPy and pandas are really about data manipulation, and matplotlib is to do some graphs. It's nice for people to know exactly what the packages are that you're importing, especially when they're not familiar packages. These are pretty familiar. os.get current working directory to just see where we are. Yeah, it's good to be in P code. I'm happy about that. Section 1, read the data. So that's section 1. Let's just have it at the top as well so that it's referenced for anybody who is reading this afterwards. How are we going to read the data? You should be familiar with that already. We did it previously in Kaggle. df train equals pd.read csv. As always, we go up one directory to, that will be the MNIST directory, then back down to input with a small I, train .csv. Good, we've read the data. How big is this data? df train shape. So we have 42,000 items in the train. Since there's 16, I'm pretty sure there's 60,000 overall, which would leave 18,000 in test. 785 columns in each of them. What are the columns? Interesting. Let's have a look. df train.columns. So in the first column, we have the label, and in the other 784, we have the pixels. The square root of 784 is 28. These images are 28 pixels by 28 pixels, and the value in each one of these columns represents how strong the color is in that pixel, varying from white to black on a grayscale. Let's just have a look at the actual data itself. df train.head, first few columns, first few rows, I mean. Let's take the first 3 rows. No, there's not a lot in there at all. That's not massively useful. Let's have a look at all of the data for the first digit. That's also not massively useful. Lots of zeros. Let's try to have a look at some non-zero values. Non-zero values are greater than 0. That will be a load of trues and falses. Now let's look at only those cases where it's true. Good, so the non-zero values are there somewhere in those 784 pixels. They vary between looking like it up to 255. That's fairly standard for this kind of image data. You can see the label of this is 1. So these pixel values are representing the number 1. We'll come back to that in a minute. Let's summarize the data and see how many of each number we have. So how do I summarize the data? df train. That's the label that I want to summarize. And I want the value counts. Good, so you can see that the number of 1s we have is 4,684. This is a pandas series. I'd rather have it as a data frame with the 1739 and so on as a column in my data frame. So to do that, I'm going to do reset index. Now it looks a little bit like that. I'll give it a name. df temp. The next thing I want to do is I want it to be sorted according to the value of the number, which at the moment is called index. So I'm going to do df temp dot sort values. So we're going to sort this data frame according to the values in the column, which is currently called index. And I'm going to say in place equals true, so that it's sorted. If I didn't do in place equals true, it would sort it, but it wouldn't save it again into the same place in the memory, and dftemp would still not be sorted. Let's give the columns some proper names, dftemp.columns. So the names now are index and label, which is not very useful. How about we call them label, which is the label of the number, and count, which is how many of those numbers we have. What does that look like? Good. The only thing I don't like about it is this index over here now is really confusing. It's probably telling you which number has most and which number has least. So the 0 was the one that was highest up by the looks of it. So there are more ones than any other number. Anyway, I'm finding that a bit confusing. I would just rather we had the index in the same order as the numbers. So reset index. I don't want the index in the data, so I'm going to do drop equals true. And now finally, that was a bit painful, but there we have it. Let's create a little matplotlib graph. Start off with creating a figure, plt.figure. So we're going to define the size. We'll add some access to this figure. Figure.add.subplot. It's a very simple. There's only going to be one graph. So it's 1 by 1, this figure, or this set of axes, and we're going to be plotting, unsurprisingly, in position 1. So 1 by 1, position 1. Now let's finally, onto this axis, put a bar chart. What's going to be the x? dftemp label, and height. Should be able to guess this. Height equals dftemp count. Sorry about that. Add wasn't dot subplot, it's add subplot. Have some x ticks. So the ticks along there are going to be the labels. Okay, well, that was annoying. I've just been gone for a little while trying to understand what was going on here. I think it's because, let's have a look at the dtypes, the types of the columns. Label over here isn't a character, it's actually being stored as an integer. I think that causes a problem. So what we're going to do is, we're going to change it to a string. So dftemp label equals as type string. Let's just check out dtypes again. Good, it's now a string. Object means string. And let's just run this code again. I had tried setting width to 0.1 because I couldn't understand what was happening. Finally, sorry about that. That was a bit painful. But what do we have here? We have a simple bar chart. 1 is the most frequent, and that is all we wanted to do. Now, after all that grief, there was a much, much simpler way of doing this, and that is using pandas itself, because pandas itself has got a load of graphs programmed in as methods. So we'll just do the same thing that we did before, which is value counts. But then we'll use the plot method, kind equals bar. And there you have it. But why did I do it the long way around with matplotlib? Well, there was a reason. See, you'll probably get used to me doing things the long way around. after a while.